The low pressure cutout switch is also known as a suction pressure control switch. It is the control that causes the compressor to go on or off as required for normal operation of the refrigeration plant. As room temperature decreases, the evaporator temperature decreases and a lower suction pressure results. When the suction pressure reaches the low pressure control's cutout setting, the LPC's contacts open and stop the compressor. As the box temperature rises, the evaporator's temperature also rises. The evaporator pressure increases, and when the cut-in settings of the LPC is reached, its contacts close and the compressor is started. The differential is the difference between the cut-in and the cut-out pressures. The differential will determine the compressor on time, the time it takes to pull the suction pressure down to the cut-out setting. Usually, it is advantageous to keep the compressor on as long as possible for maximum efficiency. For protecting the compressor from high pressure and subsequent failure, a high pressure cutout is provided that take a pressure tapping from the discharge line, and when it detects an overpressure, it stops the compressor. The HP cutout is not resettable automatically, but has to be reset manually by the operator. This is because the high pressure is a serious fault, and the cause must be investigated and corrected before the plant is started again. The high pressure cutout, as shown, is of a simple construction. It has a bellows that is set against a spring. The nut at the end of the spring is used to adjust the cutout pressure. When the high pressure gas enters the bellow expands and presses the spring. At the cutoff pressure, the movement of the bellow against the spring releases the catch and the contact is broken and the compressor cuts off. The switch arm can be pressed and the cutout reset after the cause of the overpressure has been found and rectified. Relief valves are fitted in discharge side of compressor and will lift and safeguard the compressor in the event of overpressure. One relief valve is also fitted in the condenser refrigerant line to avoid damage to the condenser if there is high pressure in the discharge line. The relief valve setting should be at least 25% above the maximum expected operating pressure to avoid seeping, but must never be higher than the design pressure of the vessel. Pressure relief valves employ a spring-loaded poppet valve as a valve element. The poppet includes an elastomeric seal, or in some high-pressure designs, a thermoplastic seal, which is configured to make a seal on a valve seat. In operation, the spring and upstream pressure apply opposing forces on the valve. When the valve of the upstream pressure exerts a greater force than the spring force, then the poppet moves away from the valve seat, which allows fluid to pass through the outlet port. As the upstream pressure drops below the set point, the valve then closes. Solenoid valve. This is an electrical signal actuated valve in the liquid line of most refrigeration system just before the TEV. This is being actuated by the thermostat in the refer compartment. The solenoid shuts off the refrigerant supply if the compartment is sufficiently cooled to the lower set point of the thermostat. Also, it connects the supply when the temperature of the compartment goes high.
If you have any questions or suggestions, please drop your comments below and we'll get back to you at the earliest. If you like this video, please subscribe to the Marine Insight channel and press the bell icon to get notified when we post such amazing videos. Please like, comment and share this video, and do not forget to subscribe to our channel.